Creatine is an organic acid that plays a key role in supplying energy for muscle cells during intense activity. Creatine is produced naturally by the body and found in small quantities in animal products. Creatine stored in muscle cells helps produce ATP, which is the primary energy currency in the body. Creatine phosphate is used to supply the type 11B muscle fibers, which are the fast-twitch high glycolytic, the ones that get largest in size, with immediate energy, ensuring that these muscles do not prematurely fatigue. This strengthens the muscular contraction of these fibers, and helps the athlete to pump out more reps, sprint at a faster rate, or engage more forcefully in whatever sport or type of exercise they take part in. Supplementing with creatine allows the muscles to store more of this high-energy molecule to provide greater gains in strength and muscle. In recent years, creatine has been studied for its post-exercise muscle regeneration properties. Findings have been very promising. In 2004, Santos and colleagues studied the effects of creatine supplementation on muscle cell damage in experienced endurance athletes running a 30-kilometer race. Closely monitoring several markers of cell damage, the researchers found that the levels of these markers were reduced after the race, compared to 16 control subjects who took only the maltodextrin. They concluded that creatine supplementation somehow reduced muscle cell damage and inflammation following the exhaustive exercise. The researchers issued the following statement. It seems creatine also helps to promote complete recovery from intense exercise. Another reason strength and endurance athletes may benefit from its use. In their impressive study, Ziegenfuss and fellow researchers demonstrated that creatine loading over just 3 days significantly improved muscle volume and cycle sprint performance in elite power athletes. For this study, 10 male and 10 female athletes were assigned to creatine or placebo groups, where, before and after the 3-day creatine supplementation period, they were assessed on repeated sprint performance and thigh muscle volume. The creatine group was given 0.35 grams of creatine per kilogram of fat-free mass, and all subjects completed 6 maximal 10-second cycle sprints with 60 seconds of recovery in between. It was found that over the 3-day period, creatine subjects experienced increased total body mass of, on average, 0.9 kilograms, a 6.6% increase in thigh volume, and increases in performance in all 6 sprints. Their anaerobic capacity clearly had improved with the addition of creatine, compared to the control subjects who took in only maltodextrin. Another important benefit for bodybuilders and strength athletes is creatine muscle volumizing effect. Creatine has a property that causes muscle cells to inflate, which produces a more heavily muscled appearance, and, more importantly, serves as a stimulus for protein synthesis. Up to 6 pounds of added body weight in the first few weeks is commonly reported in those who begin creatine supplementation, a process primarily accounted for by water moving rapidly from the bloodstream to the muscle. It has been found creatine provides a powerful anabolic boost through its enhancing of systemic methylation status. Indeed, methylation is a process that is essential for the supporting of life itself. A molecule known as SAM, S-adenosylmethionine, is the body's principal methyl donor, and a breakdown in its production can adversely affect whole body anabolism. Creatine drains the body's SAM reserves like nothing else, which, in turn, deleteriously impacts methylation status. Supplementing creatine will enhance methylation status, as it will reduce the drain on the liver and kidneys, and alleviate the body's need to synthesize creatine from amino acids. Widely known for its muscle-building benefits, creatine, it appears, has much more to offer than its ergogenic properties. Researchers Wiss and Schultz looked at the broader health implications of creatine as they tried to determine its value in treating several neurodegenerative, vascular and muscular disorders. Their findings, published in the prestigious Neuroscience, showed creatine to be an extremely important neuroprotectant. Energy metabolism and the production of reactive oxygen species, very small molecules that can result in significant damage to cell structures, of which include oxygen ions, free radicals and peroxides, are thought to underpin many neurodegenerative disorders, and creatine is thought to enhance the brain's ability to survive the metabolic and physical trauma associated with these conditions. It was found by Wiss and colleagues that those with neurodegenerative disorders associated with creatine deficiencies may require supplemental creatine, in order for it to be more effectively delivered to the central nervous system. Additionally, Ray and colleagues found creatine to improve brain function, specifically short-term memory, in normal subjects. In a placebo-controlled crossover design study, 45 vegetarian and vegan subjects, chosen as their intake of creatine was negligible, took 5 grams per day of creatine for 6 weeks. After this period, all subjects were assessed on nonverbal intelligence and verbal memory capacity. It was found that subjects who took creatine rather than the placebo exhibited improved short-term memory, and were better able to problem-solve under time constraints, significantly. Gerben and co-researchers at the Institute of Cell Biology in Switzerland found that creatine could be used successfully as an adjuvant therapy for bone fracture healing or for the treatment of osteoporosis. Based on their in vivo study, they concluded that creatine significantly enhanced the activity of alkaline phosphate, ALP, an important marker for bone growth. Cell energy, of which in their study on bone regeneration creatine played a major role, is important for bone development and maintenance, and therefore directly related to osteoporosis. Creatine, as we know, enhances cellular energy production. The researchers linked this to bone formation. Creatine might assist with the combating of diabetes, as it has been shown to improve glucose tolerance. DeRave and co-researchers showed that supplemental creatine increased glucose transporter, GLUT4, expression and muscle glycogen content while improving glucose tolerance in a previously immobilized limb. Since this study was conducted, it appears the reasons for the improvements in glucose tolerance were due to the increased expression of glucose transporter type 4. It seems the expression of this transporter was actually induced by IGF-1 and IGF-2, which are induced by creatine. As we age, there is a natural decline in the production of muscle-building hormones such as testosterone, growth hormone and the insulin-like growth factors, IGF-1. As a result, there is a natural tendency for those advancing in age to progressively lose muscle mass. As mentioned, fast twitch fibers, the type that make the bulk of our muscle size, respond well to supplemental creatine in the athletic population. These fibers are also the first to be sacrificed by the effects of sarcopenia. The powerful anabolic hormone, IGF-1, has been shown to localize in the fast-twitch fibers and, significantly, this is the hormone most likely to dwindle to a greater degree as we age. It follows that creatine supplementation into older adulthood might negate the degenerative effects of age-related muscle wasting as it enhances fast-twitch muscle fiber integrity, and, in turn, should help to maintain youthful levels of IGF-1. At least this is the possibility researchers Louis and colleagues found when they studied creatine's effects on IGF-1 and aging. Other researchers postulate that the muscle volumizing effect of creatine might switch on the gene responsible for IGF-1 production. Further research suggests advanced systemic methylation resulting from creatine use might predispose the cell for greater IGF-1 production. Which of these might prove to be the most efficient means of reducing age-related muscle wasting is up for debate, but creatine's potential as a muscle preserver in the aging population cannot be denied. Creatine has also been shown to improve isometric strength in addition to body composition in older adults, provided a strength training program is run concurrently. In their double-blind study, Brose and colleagues assigned 28 healthy men and women, over age 65, to a 14-week resistance training exercise program, during which these subjects trained 3 days a week. 14 of these participants were given 5 grams of creatine mixed with 2 grams of dextrose while the other 14 subjects received a placebo of 7 grams of dextrose. After the 14 weeks, the creatine group were found to have experienced greater increases in fat-free mass and total body mass, in addition to improvements in isometric knee extension strength. This study helps to confirm the role creatine can play in offsetting age-related muscle wasting, if combined with a strength training regime. Traditionally a group with lower creatine levels compared to their meat-eating counterparts, vegetarians stand to miss out on the benefits creatine supplies, unless of course they supplement. It was also thought that given vegetarians' initial low creatine levels, they would be more sensitive to its ergogenic effects. Researcher Burke and his co-workers studied this proposal when they compared the changes in muscle creatine, muscle fiber morphology, body composition, hydration status, and exercise performance between vegetarians and non-vegetarians over an 8-week resistance training program, in which, in double-blind fashion, 10 vegetarians took creatine and 8 took a placebo. Additionally, 12 non-vegetarians took creatine with the other 12 taking the placebo. The creatine-taking subjects initially loaded with 0.25 grams of creatine per kilogram of lean body mass for 7 days, before 0.06 grams over the subsequent 49-day period. It was revealed that vegetarian subjects who took creatine experienced a greater increase in total creatine, phosphocreatine, lean tissue, and total work performance compared to the non-vegetarians who took creatine, indicating vegetarians are more responsive to creatine supplementation. In light of the above benefits, populations most likely to experience creatine-positive effects are bodybuilders and strength athletes, the aging population, sufferers of neurodegenerative disease, those with naturally lower levels of creatine, such as vegetarians, who have a lower base level of creatine. Creatine has, in some circle numbers, gained an undeserving reputation as a harmful product. Some significant studies have helped to discredit these allegations to show that creatine is indeed a safe substance. In a 2003 study, Dr. Kreider and his colleagues found that long-term creatine use, over a 21-month period, did not pose any problems for football athletes who took 5 grams a day compared to their non-using counterparts. Indeed, the athletes who did take creatine experienced fewer episodes of cramping, muscle tightness, muscle pulls, dehydration, illnesses and contact injuries. A more recent study, May 2005, found 200 subjects taking 10 grams of creatine a day experienced no significant health differences compared to those who took a placebo, non-creatine substance. In this, a double-blind, placebo-controlled trial, subjects took the 10 grams of creatine for 310 days, during which they were periodically questioned about their health while their plasma urea and urinary creatine and albumin concentrations were measured. Both these landmark studies help to underscore the fact that if used correctly, creatine will benefit, rather than harm, one's health. In another study, Santos and colleagues found that creatine supplementation of 20 grams per day over 5 days did not result in adverse side effects such as cramping, dehydration or diarrhea. They instead found it to promote cell recovery at these dosages. Bodybuilding and strength athletes to improve size and strength have over the past decade or so popularly used creatine as a supplement. Creatine's applications stretch to many other populations: older adults, sufferers of neurodegenerative disease, and those with naturally lower levels of creatine. As shown, the processes it underpins are also quite vast, making it more than just a performance enhancer. Additionally, creatine has been scientifically shown to be safe for a majority of users. Creatine supplements come in many different types, all with their pros and cons. Monohydrate remains the #1 selling type. With all the study and debate surrounding creatine use, one thing we can be sure of is that creatine will remain at the forefront of sports supplementation for some time yet.